Geopolymer Dave. I'm here mixing up my first test batches of Woodcrete. So when I go over everything I've got here first, then I'll pause, get things measured out, and then we'll mix them up. So first off, this right here is a mix of coarser grain wood chips and finer grain wood chips that I previously mineralized. I treated first with sodium hydroxide and then with sodium silicate. So I have another video of that. And then here I have untreated. Same thing, mix of the fine and the coarser grain wood chips. I want to see if this makes any difference. Obviously, it's a lot of effort to treat with the silicate mix. It definitely feels a little bit different. This material I mineralized last, was that 2 weeks ago, I think now? And it still is a little bit damp, even though I've had it sitting in on a canvas drop cloth. So these wood chips definitely like to absorb moisture, that's for sure. This is obviously dry. If you were to include mineralizing as part of the industrial process, you want that to be fully dried through probably some kind of a low temperature oven or something like that. This mixture here, I'm getting a little bit low on metakaolin. I need to calcine some more. But what I did is I mixed half and half metakaolin and diatomaceous earth. This is a bit of an experiment. Diatomaceous earth is microsilica. It's amorphous from diatoms, which are tiny creatures that form in the ocean. Some of the literature I've read suggests that it is pozzolanic and can be used for geopolymers. I've not done anything with it yet, so I'm not sure. And there are two reasons why I'm trying to use diatomaceous earth. One, I want to experiment with different materials which are pozzolanic and offer some different alternatives to metakaolin, which is obviously going to be, well, I'm not sure if it would be more expensive than diatomaceous earth, but I'm just experimenting with different materials. The second reason why I'm interested in diatomaceous earth is that it's extremely low density. So those diatoms, the little skeletons of the diatoms which are left, those are hollow essentially, and so they are very low mass, and I'm trying to make a lightweight geopolymer that can be used for obviously building blocks. I have a couple of different ideas of materials that might work well for making lightweight geopolymers, including things like the microspheres, silica microspheres. Silica fume is essentially silica microspheres, but there are different ways that you get microspheres. Another material I'm interested in is foamed glass. They take recycled glass and they foam it. They obviously heat it up to make it molten, and then they percolate gases through it, quench it very quickly, and then I'm not sure all the processes involved, but anyway, you end up with a foamed glass which can be broken down into material that could be used as an admix. The other natural material that I'm interested in for lightweight geopolymers is pumice. I think pumice could be a very interesting material as well. Now, in order to reduce the cost of geopolymers, I think we need to get creative about the precursor materials and where you get them. And then we'll need to locate the manufacturing of geopolymers in places where these materials occur, so that we can bring the materials together, have them without having a lot of transportation costs, and then hopefully the only transportation cost would be the final. So that's what this is half metakaolin, half diatomaceous earth. In this container I have the sodium silicate, sodium hydroxide solution. It's just the standard mix that I got out of this book, Geopolymer Formulations. And this is what I've used for my other geopolymer experiments. So there are some ready-made sort of recipes, if you will, in here, which makes it easy, and then I've adjusted these a bit. So this one is what he calls formulation C. Metakaolin plus microsilica plus sodium water glass plus sodium hydroxide. So I just substituted the microsilica for, or the diatomaceous earth for the microsilica. So what I'm going to do is make 2 test mixes in these containers. These turn out to be really useful containers for making test bricks. They're actually pocket cabinet screw containers, but they're very robust, and the geopolymer pops out very easily. And they also have these nice lids that I can put on in order to keep the moisture in, which is an important part of the process. So I've got everything ready to go. I'm going to pause, measure out some contents, and then I'll start running again.